Day 553 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2528. Maximize the minimum powered city. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given the zero index integer array stations of length n, where stations of I represents the number of power stations in the ith city. Each power station can provide power to every city in a fixed range. In other words, if the range is denoted by R, then a power station at city I can provide power to all cities J, such that the absolute value of I minus J is less than or equal to R, and 0 is less than or equal to I, and J is less than or equal to n minus 1. Note that the absolute power of x denotes absolute value. For example, the absolute value of 7 minus 5 is 2, and the absolute value of 3 minus 10 is 7. So with the absolute value, we're just counting how far away is it from 0. So if it's negative, it's still 7 away from 0. If it's positive, it's still 7 away from 0. That's how that works. Then the power of a city is the total number of power stations it is being provided power from. The government has sanctioned building K more power stations, each of which can be built in any city and have the same range as the pre-existing ones. Giving the two integers R and K, return the maximum possible minimum power of a city if the additional power stations are built optimally. Also, note that you can build the K power stations in multiple cities. All right, y'all, so I can understand how that may be difficult to understand. So let's take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, our input stations equals an array of integers 1, 2, 4, 5, and 0. R equals 1. K equals 2. The output is 5. So let's take a look at this explanation to see how they got this output from this input, right? So it says one of the optimal ways is to install both of the power stations at city 1. The stations will become an array of integers 1, 4, 4, 5, and 0. So let's break that down first before we move on. We have K power stations. The government has sanctioned building K more power stations, each of which can be built in any city and have the same range as the pre-existing ones. So we have 2 more power stations that we can build in any one of these stations, right? And they tell us we should build at station 1, which is index 1. So station 1 is index 1. That's what this means right here. Boom. So come to index 1 and we add both of these 2 power stations. So now this 2 at index 1 now becomes a 4, and the array now looks like this. Boom. Now that the array of power stations looks like this, we can start seeing how, or checking to see how much power each station is generating, right? And the range is 1. So that means we could look 1 to the right. Say we're looking at this 2, right? We could look 1 to the right and we could look 1 to the left when we're getting our power stations, because the range is 1. If the range was 2, then we go 2 to the right and 2 to the left. But in this case, the range is 1, so we're going to stick to 1. Now let's see how they did it. So it says city 0 is provided by 1 plus 4, which equals 5 power stations, right? So this 2, or we're looking at this array now. Boom. We go 1 to the left. Or excuse me, we're starting right here though. We're starting at index 0. So we go 1 to the right, we get 4. 1 plus 4 is 5. We can't go to the left because there's no power stations over there. So we just do this 1 plus 4, which equals 5, because there's no power stations to the left, right? So boom. Then we do the same thing for city 1. And city 1 is provided by 1 plus 4 plus 4 equals 9 power stations. So city 1, this is city 1 right here. When we go, remember we have the range. So we go 1 this way, 1 plus 4 is 5. Then we also go 1 this way, 5 plus 4 is 9. So altogether it would be 1 plus 4 plus 4. Boom, that's where this comes from right here, and that's equal to 9. Then we go to city 2. So now we're at city 2 right here. We go 1 this way, and we go 1 this way. So in total, it'll look like this, and we go 4 plus 4 plus 5 equals 13. So that's how we get this 13 right here. Boom. Now we're going to move to city 3. This is city 3 right here. Same thing. 1 to the left for the range and 1 to the right. So altogether, this is what we're looking at right here. Boom. 5 plus 4 is going to equal 9. So that's where this 9 comes from, right? We go 5 plus 4 right there. Boom. And then finally, we are right here at the city 4. And city 4, we could go 1 to the right like we did. Excuse me, we could go 1 to the left, but we can't go to the right similarly to how we were at index 0. So we could just do 5 plus 0, and that's going to be 5. Then it says, so the minimum power of a city is 5. Since it is not possible to obtain a larger power, we return 5. So what that just means, if we would have put this 2 anywhere else, the minimum city would be lower than this 5, right? And this is the maximum. So this is the maximum possible minimum power city, right? So if we would have put these 2 power stations anywhere else, the most minimum station would have been lower than 5, right? But we want the maximum minimum station, right? So in this case, that's how we got it, is 5. So I hope that makes sense to y'all. Just in case it didn't, let's take a look at example 2. We're not going to go all the way through it like we did up here, but it's pretty simple because all of the elements are the same. So in example 2, we have the input stations equals an array of integers 4, 4, 4, 4, r equals 0, k equals 3. The output is 4. It says it can be proved that we cannot make the minimum power of a city greater than 4. So y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is not that difficult at all. So let's get into it. Now, the first thing we need to do is we're just going to get declare a variable called n. We're going to say let n, and we're going to get stations.count. So we're going to say let n equal stations.count. Boom. Then we need a prefix sum array to quickly calculate the power in any range. So we're going to declare a variable called prefix, and we'll set that equal to an array of integers. So square bracket int, come outside the square bracket, open up the parentheses and put repeating, colon 0, comma, count, colon n plus 1. Boom. Then we're going to build the prefix sums of station power. So we're going to come underneath this, and we're going to say for I in 0 dot dot less than n. We're going to open up the brackets, and we're going to say prefix square bracket I plus 1. We're going to set that equal to prefix square bracket I. Come outside that square bracket, and we're going to say plus station square bracket I, just like that. Then we are going to come underneath this for loop. We're going to create another variable called power and set that equal to an array of integers. Come outside that square bracket. We're going to open up the parentheses, say repeating, colon, 0, comma, count, colon, n. Boom. Then we come underneath that. We'll say for I in 0 dot dot less than n. We're going to open up the bracket, and we're going to calculate the range. So it'll be I minus R, and then it'll be I plus R for the range, right? So remember, if this was I, we're going to check I minus R and I plus R. In this case, when R was 1, right? So that's how we're getting the range. So we're going to say, first we're going to come right here. We're going to say let left equal max, open up the parentheses, 0, comma, 0, comma, I minus R. Then we're going to come underneath this. We're going to say let right equal min, open up the parentheses, n minus 1, comma, I plus R. Boom. Then we're going to compute in this window using the prefix sum. So we're going to come underneath this, and we're going to say power square bracket I. We're going to set that equal to prefix, open up the square bracket right, plus 1, come outside the square bracket, minus prefix, square bracket left. Boom. Now we're going to use binary search on a possible minimum power value. So for that, we'll come underneath this for loop, and we'll declare a variable called low, and we'll set that equal to power.min, put the parentheses and the exclamation point. Then we'll declare another variable called high and set that equal to power.max, put the parentheses, exclamation point, and then we're going to say plus k. Then we're going to come underneath that, declare a variable called ands, and set that equal to low. Boom. Now we're going to create a helper function so we can make every city's power greater than or equal to the target, with that being less than or equal to k new stations. So we'll come underneath this and we'll say func can, open up the parentheses, we'll say underscore target, then we'll say colon, put the integer, come outside of that, we're going to return a boolean, open up the brackets, and we're going to declare a variable called added, and we're going to set that equal to an array of integers. Come outside of that, open up the parentheses, we're going to say repeating colon 0, comma count colon n. Come underneath that, we're going to declare a variable called window add, set that equal to 0, and this is going to be a running window of active added power. Then we're going to declare a variable called remain. We're going to set that equal to k, and that's going to be the remaining new stations we can add. Come underneath that, we're going to say for I in 0 dot dot less than n. We're going to open up the brackets, and we're going to slide the window, y'all. We're going to slide the window and remove the effect of stations that no longer affect city of I. So we're going to come underneath this, and we're going to say if I minus r minus 1 is greater than or equal to 0. We're going to open up the brackets, and we're going to say window add minus equals added square bracket I minus r minus 1. Boom. But we're not done yet. We're going to come underneath this if. We're going to start another if. And this is, so if the current power is less than the target, we need to handle that by saying if power square bracket I plus window add is less than target, boom, we're going to open up the brackets, and we're going to say let need equal target minus, open up the parentheses, power square bracket I. Come outside of that, we're going to say plus window add. Boom. And then if not enough remaining new stations, we're going to fail early by just coming underneath this, and we'll just say if need is greater than remain, then we could just open up the brackets and return false. Boom. Then we'll come underneath that, we're going to say remain minus equals need, and we're going to add need to the new stations at the farthest effective index, meaning I plus R. So we're going to say let IDX equal min, open up the parentheses, n minus 1, comma, I plus R. Then we're going to come underneath that, we're going to say added square bracket IDX. Come outside of that, we're going to say plus equals need. Then we're going to come underneath that, we're going to say window add plus equals need. Boom. Then all cities reach the target with k new stations, we can return true. So we could just come right here and say return true. Boom. Now we need binary search for the maximum minimum power achievable. So we're going to come underneath this right here, and we're going to say while low is less than or equal to high, we're going to open up the brackets. We're going to say let mid equal, open up the parentheses, low plus high, come outside those parentheses and divide that by 2. Then we're going to say if can, y'all, come underneath this, and we're going to say if can, open up the parentheses, pass in mid, come outside those parentheses, open up the brackets. If it's achievable, we're going to try to increase the target by saying ands equals mid. Come underneath that, we're going to say low equals mid plus 1. Then we'll come right here and we can say else, open up the brackets. Otherwise, we'll just lower the target by saying high equals mid minus 1. Boom. And finally, last but certainly not least, we need to come right here and we could say return ands, y'all. That's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. And we have an error. This should be high. Sorry about that. Let's run it again. Let's see. It's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 18 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom part, y'all. And yeah, that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.